Hey everyone. So at this point, you would have seen our other videos involving how to use the various instruction sets within Proficy Machine Edition, beginning with coils and contacts to more advanced instruction sets such as rising triggers, falling triggers, timers, arithmetic operations, relational operations, call blocks, commenting, etc., etc. And now it comes time to start challenging ourselves and to develop a logical program which uses maybe not all of the instructions we've discussed, but at least some of them to start challenging ourselves. Now, what we have in front of us is an assembly line conveyor system program that I've developed and will very shortly show you the solution to, but I encourage you to take a look, try it out yourselves, and then come back to the video to see the actual solution. So for now, I'm going to walk you through the program, and then afterwards, I'll show you the logic. So this is the program. It's an assembly line that once again uses a conveyor system to move boxes from a production area to a packaging area, and it uses an optical sensor to sense whenever a box is moving to the packaging area. Now the system is equipped with the following inputs. We have a selector switch with two positions, automatic or manual, which we'll call auto_mode in terms of the variable name in our program. It's a Boolean variable, and when it's equal to 1, we call it's in the auto position, and then when it's 0, we call it as it being in the manual position. We have a start push button, which is a Boolean variable called start_PB, and when it's equal to 1, we assume the push button has been pressed. Otherwise, if it's 0, it's been depressed. Likewise, we have a stop push button called stop_PB, which is the Boolean variable where when it's equal to 1, it's been pressed, and if it's 0, it's depressed. We also have an emergency stop push button, which is a Boolean variable in the program called eStop_PB, where when it's equal to 1, it's been pressed, and 0 meaning it's been depressed. Then we have the optical sensor, as previously mentioned, which detects boxes moving on the conveyor. This is a Boolean variable in the program called part_detected. And this is going to be true whenever the conveyor is running and the self-resetting timer with a 2-second delay elapses. And it's only going to be true for one scan, again, whenever this timer elapses. So we're basically simulating a part being detected anytime the conveyor is running and the self-resetting timer has elapsed, meaning every 2 seconds it elapses for one scan. Now we also have the number of boxes set point, which is the operator set point to determine the number of boxes we're going to be sending to the packaging area from the production area. It's going to be an integer variable in the program called operator_set point. Now let's talk about some of the logic. Let's talk about automatic operation. So when we're operating in automatic mode, based on the selector switch, the operator will set the number of boxes to be sent to the packaging area via an HMI or human machine interface, and they're going to enter that in through like soft push buttons using a touch screen. And when the operator places the selector switch afterwards to the automatic position after setting the number of boxes, then the PLC will automatically start the conveyor, and then using an up counter instruction, whenever the PLC detects that the number of boxes passing by the optical sensor has reached this operator set point, then the PLC will command the conveyor to stop. And the conveyor will remain off until the operator presses the start push button to restart the conveyor system all over again. Now let's talk about manual operation. Whenever the system is operating in manual mode based on that selector switch being in the manual position, then the operator has full control of the system and may press the start push button to start the conveyor system or press the stop push button to stop the conveyor system based on their prerogative, anytime they want. And in manual mode, we have to be sure that the PLC does not track the number of boxes passing by the optical sensor and keeps the count always as 0. So we're giving the operator flexibility here to control the system in manual mode. Maybe they just want to bump the conveyor. Maybe they just want to start a bit and stop a bit. So we're not tracking the number of boxes passing by the optical sensor, and we have to keep the count always as 0. Now let's talk about automatic to manual mode bumpless control. So whenever you're moving from automatic mode to manual mode via that selector switch, if the conveyor system was previously running in automatic mode, and now you've moved it to manual mode, then the system, if it was previously running, will continue to run. We call that bumpless operation. And if it was previously not running, then it will remain off when you move it to manual mode, whereupon the operator can, at their prerogative, decide to start the conveyor system. Now, we also have emergency stop safety control integrated in our PLC logic, such that whenever the conveyor system is running and the e-stop is engaged, it doesn't matter if you're in automatic mode or manual mode, whenever that e-stop is pressed, then the system will stop the conveyor. And once and only once the e-stop is depressed, then the system will start once the operator presses the start push button. So there you have it, a conveyor system for an assembly line, and we have the logic outlined here. So go ahead, maybe pause the video, try it out yourself, see if you can put together the logic, and at that point, come back to the video. And without further ado, let's get started. Let's show you the actual solution for this challenge program. So here's our program. Let's walk through the logic from top to bottom. So here we go. We're using a self-resetting T-on or timer on delay timer such that every 2 seconds the timer elapses, and as long as the conveyor is running, we're using that to simulate that a part is being detected. Because we're assuming that as long as the conveyor is running, maybe it's a constant speed conveyor and a box is moving on it, every 2 seconds it's going to pass by our sensor meaning our part is detected, and therefore for one scan it's going to show that the part underscore detected variable will be equal to 1. Now let's skip ahead to the next routine, to the next set of rungs. We can see here, this is our kind of auto logic and manual logic, auto mode and manual mode logic for the conveyor running status. Now, here we have our conveyor running indication. This is the conveyor underscore run variable. Now I've just decided to call it this way. You can call it whatever you like. And we can see here, whenever we are not in auto mode, if I press this push button, now it's pressed. And we could see here that we are not in auto mode because auto mode is false using this normally closed contact. If I release the start push button, now it's depressed. We can see we've latched in our conveyor, it is running. And if I decide to click the stop push button, the conveyor stops. And if I release the stop push button, the conveyor is still stopped until I press my start push button. And if I release the start push button, once again, the conveyor is now latched in and it's running. And if I press my emergency stop push button, then the conveyor is forced to stop, and if I therefore try to press my start push button, the conveyor is not going to start unless I release or depress my e-stop, my emergency stop push button. Now that it's been released, it's depressed. If I click my start push button, the conveyor will once again run, and then if I click my stop push button, the conveyor will once again stop. Perfect. Now let's run to auto mode. We're going to actually come back to this routine. We're going to come back to this rung as soon as we first examine the auto logic. So let's just quickly jump over to our auto logic. And we can see here, in auto mode, whenever the number of parts sensed reaches the number of parts sensed set point, we stop the conveyor. So this is only in auto mode. So let's take a look here at, we're using an up counter instruction, our PV, or in this case our process variable, or our preset value is equal to the operator set point. So we want to basically, in auto mode, sense 10 moving boxes passing our sensor and then stop the conveyor. And every time 10 boxes is counted, we can then at that point start the conveyor up again, whereupon it will count another 10 boxes. So let's just take a look at our inputs first. When we're in auto mode and we have not reached our set point, which is basically meaning we haven't reached 10 boxes, as long as the conveyor is running and we've detected a part, then therefore we will increment our parts counted. Every single time there's a change in the part detected, which again is driven based on that timer above in rung number 1. And if we count the number of boxes that are equal to 10, and that happens, then parts underscore set point underscore reach will be true. And then if that's true, then if we look down or here in our logic, we're in auto mode and we've reached those number of parts, then that will make this true, whereupon our auto start command will be false. And when this auto start command is false, if we go back up, we can see here if we're in auto mode and our auto start command is false, then our conveyor is commanded to stop. And if it's commanded to stop, then the conveyor will stop. So let's quickly test that. If I move to auto mode, conveyor immediately starts. We can see here we are detecting our parts. This is basically going on for every scan, every 2 seconds, based on our self-resetting timer, because every 2 seconds we're counting up. And eventually, we're going to reach our 10 as our set point, and now it's 10. And now we can see now that it's equal to 10, we've reached the parts set point. Therefore, we're no longer going to be detecting any future parts, because it doesn't matter at this point whether or not we have a part detected. Never mind, the conveyor is not even running, but we're not going to even care about counting up anymore, because we're basically preventing this power flow based on this parts set point reached variable now being true, because our CV, our current value, has reached the preset value. And now we are basically latched. We are basically setting this as true until we reset the timer. Now, how do we reset the timer? We're gonna need somebody to click that start push button to send power flow to the R input, which is our reset input, to once again reset the parts counted, whereupon, because we reset that, and that will now make this false, as long as we're in auto mode, we're going to set our auto start command back to true, meaning our conveyor will start to run again. So if I hit this start push button, now I'm going to release it, and we can see we are counting the number of parts, because now our conveyor is running. We can see our start command is now true, and as soon as we reach those 10 parts, we're at 5, 6, 7, 8, 9, and 10. We should see this turn off, and it has, and our conveyor is no longer running. And we can see that this has no influence on the logic as we had beforehand if we were in manual mode, because remember, we need to be in manual mode for this to execute, so it's not going to have any influence. And therefore, because we're in auto mode and we've lost our auto start command, then the conveyor will stop. Now, if we were to flip to manual mode, now we're in manual mode, we can see here we are always keeping this set point, this current variable, this current value as 0, based on our logic conditions. Remember, if you recall from the manual operation, the PLC does not track the number of boxes passing by the optical sensor and always keeps the count 0. Therefore, because we're in manual mode, we're constantly resetting the up counter by keeping the parts counted as 0. Therefore, when we move back to automatic mode, we can see here now we're no longer resetting it to 0, and therefore, because we haven't reached the parts reached, then we are always keeping the conveyor running until we've reached 10, whereupon we will stop the conveyor itself. Now, let's talk about the emergency stop operation in automatic mode. So let's go ahead and we've just reached our parts counted. Now let's go ahead and let's start up the conveyor. Now we're running. Now let's go ahead and engage our e-stop. We can see here based on this logic, this is sort of our prohibit logic. This is our interlock. So if I engage the e-stop, we can see we have our auto interlock condition, and we can see here we've basically reached 5 parts of our 10 set point. And because we've reached our interlock, the conveyor is stopped. So if our interlock is engaged, which it is, because it's on, therefore this normally closed contact has a value of 0, and therefore we've stopped this conveyor from operating. And we can see here, if we release the e-stop, we're essentially latched in. We've latched in our auto interlock, because if you recall from the logic description, when we get an e-stop, only once the operator presses the start push button do we allow the system to restart back from where it was. So we can see here we've caught the auto interlock, and we're in auto mode, but because we haven't quite yet pressed our start push button to restart the system once we've recovered from the e-stop condition, then the conveyor hasn't run yet. So if I go ahead and I click my start push button, we've now removed the auto interlock, and now we're moving once again from 5, now we're 6, 7, 8, 9, and finally 10, where we'll stop the conveyor system. Awesome. Now let's talk a little bit about bumpless control. So if I moved from auto to manual, if you recall, if the conveyor was previously running, it will continue to run until an operator decides to stop the conveyor, because you're in manual mode. Now if I start my conveyor in auto mode, because we've reached the set point, now I'm going to start it. Now we are running, and what happens if I toggle the conveyor from auto to manual? So we can see it's running, I'm going to toggle it, now I'm in manual mode, and you'll notice the conveyor is still running, we're latched in. Now why is that? Well, if the conveyor was previously running, and we've just toggled the auto mode, as long as we haven't touched the stop push button, then the conveyor running status will remain as true. therefore we will continue to run, whereupon I can click my stop push button to stop the conveyor, and then click my start push button to start the conveyor once again. Now what happens if I'm in manual mode and I click my e-stop? If I click it and the conveyor is running, it will stop the conveyor. If I bring back the e-stop and I depress it, then I can click my start push button to start the conveyor once again. And there you have it. If I just do the last condition where if I'm in auto mode and at this point my conveyor is asked to run and I decide to wait until the parts count has reached the operator set point whereupon the conveyor will stop, we should see the conveyor then stop. We should see it stopped now. Waiting for the stop, there it is. And if I move to manual mode by toggling my auto mode variable, we'll see that the conveyor remains as stopped until I press the start push button to start the conveyor, or then click the stop push button to stop the conveyor. And if I moved from manual mode to auto mode whilst the conveyor is running, well, it's going to continue running until we reach our parts count set point, which is the operator set point variable, which is equal to 10. So we're going to wait here, 5, 6, 7, 8, 9, and 10. And we should see the conveyor running status turn off. So that's your solution. I hope you found this video informative. Thanks for trying the program, and thanks again for tuning in.